Hello everyone. The last video was about my measurements for pipe length and head height for different sections in the terrain I'm at. You've also seen my small hoverboard turbine that I showed. Yes, now I want to get into the data I collected, go into the different sections I measured, discuss some different turbine placement options. I thought about two stages, stage 1 and stage 2. I'll go into power expectations for stage 1 and stage 2, and then I'll go into the costs only for stage 1 and stage 2 can be added additionally later on. So let's look into the pipe length and pressure for the different sections. You saw me in the last video with a pressure gauge and my pipe pulling over the terrain. So I'll show you right now what I measured. I have, first of all, in the first video, I already measured the pipe length of section A, which is from the water intake down to a flat spot. I measured 2 bar there, which is around 30 psi. Then we have a flat section which is 45 meters long with a head height of 9 meters or 0.9 bar. I put a question mark there because I doubt it that it's really that much, but it's hard to tell. And the last section is beginning at the end of section B and going down all the way to the river, so that is 0.0. I can't go any further into this direction. I might just go put the water intake further up to increase my pipe length. Anyway, section C is 48 meters and 2.1 bars, so this is the steepest section. As shown, my house is around about here, which is relevant for mainly cable length from the turbine to my house. Let's go into the first option, turbine placement stage 1 in section A. So I pick up the water up here in the water intake, obviously, go down 67 meters of pipe and place my hoverboard pelton turbine with just low voltage down here, and I have only a cable length of around about 60 meters to my house, which is very short. Now I might go further down and try to add section B, but as you can see, I don't really pick up much height here. So if I take section B, I also have to take section C because then it's getting really interesting. So we basically skip one option of adding section B, which would be right here, and we go straight to section C. Put the pelton down here, which is section A plus section B plus section C brings us to a pipe length of 160 meters and a total pressure of 5 bar or a head height of 50 meters. This would be pretty much taking the whole potential. But it also comes with a much higher cable length, which is especially critical with low voltages. So at this point, I wouldn't take the pelton, the hoverboard pelton with low voltage. I would have to go, either I would have to increase the voltage, which results in losses, or I have to buy very big cables, which is expensive. So the best option here would be to go with a washing machine, pelton wheel. These motors go up to 400 volts, and therefore the cable size could be reasonable. Okay, let's go into the power expectations. We are now looking at the Excel sheet where I collected all the data from video 1 and 2. Video 1, I was measuring the flow rate for the 20 millimeter pipe, which was completely filled with a flow rate of 0.3 liters per second. I measured flow rate for 50 millimeter pipe. This pipe was not filled, so I estimated I could triple this value easily. So we will be mainly looking at this line here, because obviously 20 millimeter pipe does not have enough power to generate any electricity. Well, it has the power, but the losses with the flow, even this flow rate, are very high. So we have to go to a bigger pipe size. Down here you see the kinetic energy the water has for different head heights. So yes, this is just the kinetic energy for the different pipe sizes. I estimate an efficiency of 50%. And now comes the interesting part. At a head height of 20 meters, which is my stage 1 scenario, I would be getting 133 watts into my batteries. At stage 2, with a head height of 50 meters, I would get 334 watts into the battery. Now let's look into the cost for my pelton wheel at stage 1. I'm going with a 50 millimeter pipe, which is €1 in Bulgaria, €1 per meter. I'm estimating 100 meters because I don't think I can cut it. I think I have to pay for 100 meters. With this 50 millimeter pipe, I'm already set to go to section A, B, and C, so to establish stage 2. You can see with a pipe length of 160 meters and a flow rate of 1.5 liters per second, I'm still at 90% efficiency. I'm planning right here with a flow rate of 1.36, so I have some room to play with right there. Then next up we have the pelton wheel, which I 3D printed. You can either buy them probably for €50. The filament itself for the 3D print is probably 5 to 10 euros. But you also have to buy bolts. I had to buy the aluminum frame I built. Some nozzles or something is all included right here. Next up, we have the hoverboard motor. You can get them second-hand for free most of the time. Only the battery or some other things inside died. So you can buy a broken one and probably the motor is still intact. You get 2 motors for around 10 euros. Use only one, so it's 5 euros right here. But these run with a relatively low voltage, so if you run them with a higher power, you have to go to bigger cable size. Since I'm have solar cable lying around, which is 2 times 6 square millimeters, I will be using this, which adds quite some costs to this project. ChatGPT said 2 times 4 square millimeters would be fine as well for the power I am planning to run right here. But you have to calculate that yourself for your project. The next up is MPPT charger. In my case, I'm using a Victron 100/20, which is 100 volts max and 20 amps max. I have that lying around as well, so you might as well go for a smaller version right here. I bought that second hand for 53 euros, which brings us to a total cost of 364 euros. All of this I've already spent on it, so I just need to find the right pipe and buy it and install it, and then we can see if it will work out. Down here I made some estimations how much euro per kilowatt hour I will be paying for my electricity if I build this project. I'm planning to run this system for 4 months every year, because in the summer month the water will not be running, so it's only operating in 4 out of 12 months. Here's my battery energy, my energy that I plan to produce in stage 1, and this will be resulting in 385 kilowatt hours every year. And as you can see, of course, the first year it is still almost €1 per kilowatt hour, but the longer I will use this system, the cheaper it will get. With this value, I'm able to compare this option to other options. I might, for example, add the cost for stage 2 right here and see what that costs. And as you can see down here, I also made some estimations for a water wheel down at the river, which would be a totally different concept with its pros and cons. If you like, I can go into this as well. And yeah, I have to compare it to solar as well, because solar is relatively cheap. But the problem is in the winter month, it doesn't produce very much. So yeah, if you like to see a comparison of all the options I basically see in my situation, let me know in the comments. And yeah, stay tuned for the next part. Probably it will be once I bought the new pipe, because without the pipe, nothing will happen. All right, like, subscribe, and see you in the next video. Thanks for watching. Bye bye.